Hi, hello, namaskara. In today's session, we are again starting with the chapter number 3, current electricity. In that, today we are dealing with two parts. One is mobility. Thereafter, we are getting into the limitations of Ohm's law. Okay, before getting into the theory part, we have to go through some basics points which we have read in the last sessions. Okay, that is first point I make you to remember. In the last sessions, we derived through the equation of drift velocity. What is the equation for the drift velocity? Vd is equal to, yes, minus E into E whole divided by M into tau, where tau is the relaxation time ಅಂತ ಕಲ್ತಿದ್ವಿ. ಅದೇ ರೀತಿ ಇದನ್ನ ನಾನು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ತಗೊಂಡಿರೋದ್ರಿಂದ ಏನು ಬಂದಿದೆ, ಸೈನು ಮೈನಸ್ ಬಂದಿದೆ. ಅದೇ ಒಂದ್ ವೇಳೆ ನಾನು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂತ ತಗೊಂಡ್ರೆ ಅದು ಪಾಸಿಟಿವ್ ಬರ್ತದೆ. ಬಟ್ ಟು ಮೇಕ್ ಇಟ್ ಈಸಿ ವಿ ಹ್ಯಾವ್ ಟು ಕೀಪ್ ವಾಟ್ ನಾವು ಹಿಯರ್ ಮಾಡ್ ಓವರ್ ಇಟ್. ಮಾಡ್ ಇಟ್ಬಿಟ್ಟು ಅಂತಂದ್ರೆ ಇದು ಮೈನಸ್ ಇದೇನಾಗ್ಬಿಡ್ತದೆ, ಪ್ಲಸ್ ಆಗ್ಬಿಡ್ತದೆ. ಅದೇ ಫಾರ್ ಆನ್ಸರ್ ಗೆಟಿಂಗ್ ಇಟ್ ಟು ಬಿ ಈಸಿಯರ್ ಒನ್. ಓಕೆ, ದೇರ್ ಆಫ್ಟರ್ ಫಾರ್ ಟುಡೇಸ್ ಸೆಷನ್ we need the discussion of Ohm's law. Therefore, I'll take the make the equation of Ohm's law. V is equal to I into R, where R is the resistance, I is the current, V is the potential difference. Here we can say V is directly proportional to I. More is the potential difference, more is the current I am obtaining. Okay, if I draw the graph for that, V versus current, okay, that will be a straight line because the information what we are getting through this equation is linear. Therefore, this is how we are getting the graph. And if I take the slope over it, it will give us the resistance, because this is nothing but what now here, change in the current, that is delta I, and this is nothing but the change in the potential difference. Okay, change in the potential difference. Therefore, if I name them ABC, if I name them here ABC, therefore I can say here tan theta, otherwise slope is equal to tan theta is equal to AB by BC, AB by BC. Okay, if I take it here AB, what is that now? AB is what now? It's a change in the current, therefore delta I whole divided by, what is BC? BC is what now here? Potential difference, delta V. But what I want to know here, I want to get the resistance. This is nothing but the slope ಅಂತ ಹೇಳ್ತೇವೆ. M is equal to tan theta ಅಂತ ಕೂಡ ಹೇಳ್ತೇವೆ. ಅಂತಂದ್ರೆ ನನಗೆ ಬೇಕಾಗಿದ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಕ್ವೇಶನ್ R is equal to V by I. ಬಟ್ ಇಲ್ಲಿ ನಮಗೇನ್ ಬಂದದ, I by V ಅಂತಂದ್ರೆ ಬಂದಿರೋ ಸ್ಲೋಪ್ ಅನ್ನ ರೆಸಿಪ್ರೋಕಲ್ ಮಾಡ್ಕೋಬೇಕು. ಅಂತಂದ್ರೆ to get the resistance we have to take the reciprocal of the slope. Therefore 1 by m is equal to ಏನಾಗುತ್ತೆ, ಇದನ್ನ ರೆಸಿಪ್ರೋಕಾಲ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, that is delta I by delta V ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, delta V divided by delta I ಸಿಗುತ್ತೆ. ಅಂತಂದ್ರೆ ಅದೇನಾಗುತ್ತೆ, ಈ ಫಾರ್ಮುಲಾಗಳೇ ಬರ್ತದೆ. Okay, these are the points I think we have read in the last sessions. Now getting into the today's session, that is it's the mobility. Okay, if I ask you two words, what do you mean by the mobile and immobile? Okay, it's a very familiar for everybody now. Okay, and if I ask you now, what do you mean by the immobile? Okay, okay, if you think of it, mobile, when I say, the first idea come in your mind, which is under motion. Remember, which is under motion, I can say that is a mobile body. Okay, which is not under motion, then I can say it's a immobile body. Okay, for example, if I take a cell phone, example of cell phone, otherwise mobile, what we are using, that is always moving. Therefore, we are calling it as what now? Mobile. Similarly, if I check out for the landline, is it moving? No, it is under always rest. Therefore, we are calling that as a immobile body. On the same idea, now we have to understand about the electron. But before getting into the electron, I will take analogy. Okay, if I take two people, okay, he's very thin now, and another man, otherwise another person, I'll take it, he's too much fat now. Okay, if I ask you who is having the more motion, then yes, readily you'll tell that the person who is lean, otherwise thinner, he is having the more motion and he is having the less motion. He is having the more motion, he is having the less motion. Therefore we are calling it as he is having more mobility. This person is having more mobility comparing to this fat person. On the same way we have to explain for the electron. If I ask you how to understand the electron's mobility, okay, before getting into that, one point must be clear now. That is, when I say the mobility for the electron, then electron must be under motion. Yes, that is right. But how to explain the mobility? Mobility will be observed only when I explain about the velocity, right? ಒಂದ್ ವೇಳೆ ವೆಲಾಸಿಟಿ ನಾ ಹೇಳಿದ್ರೆ ಮಾತ್ರ ಏನಂತ ಹೇಳಿಕ್ ಬರ್ತದೆ, ಮೊಬಿಲಿಟಿ ಹೆಚ್ಚಿಗೆ ಇದೆ ಮತ್ತೆ ಕಡಿಮೆ ಇದೆ. ಯಾಕಂದ್ರೆ ಈ ಪರ್ಸನ್ ನೀವು ಹೆಚ್ಚಿಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀರಿ ನೀವು? ವೆಲಾಸಿಟಿ ಹೆಚ್ಚಿಗೆ ಇದೆ, ಮೊಬಿಲಿಟಿ ಹೆಚ್ಚಿಗೆ ಇದೆ. ಬಟ್ ಈ ಪರ್ಸನ್ ವೆಲಾಸಿಟಿ ಏನಿದೆ ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಅಂದ್ರೆ ಏನಾಯ್ತು? ಮೊಬಿಲಿಟಿ ಕೂಡ ಕಡಿಮೆ. ಅದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗೂ ಕೂಡ ವೆಲಾಸಿಟಿ ಹೆಚ್ಚಿಗೆ ಇದ್ರೆ ಮೊಬಿಲಿಟಿ ಹೆಚ್ಚಿಗೆ ಅಂತ ಹೇಳ್ತೇನೆ, ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಇತ್ತಂತಂದ್ರೆ ಮೊಬಿಲಿಟಿ ಕಡಿಮೆ ಇದೆ ಅಂತ ಹೇಳ್ತೇನೆ. ಬಟ್ ಇದನ್ನ ಈ ಚಾಪ್ಟರ್ ಒಳಗಡೆ ಹೆಂಗ್ ನೀವು ಹೋಲ್ಡ್ ಮಾಡ್ತೀರಿ? ಈ ಚಾಪ್ಟರ್ ಒಳಗಡೆ ನೀವು ಎಲೆಕ್ಟ್ರಾನ್ ವೆಲಾಸಿಟಿನ ಯಾವ ವೆಲಾಸಿಟಿ ಅಂತ ಹೇಳ್ತೀರಿ? ದಟ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್ ನಾವ್ ಹಿಯರ್? drift velocity. We are explaining what now here? Drift velocity. Therefore we understood that which electron is having more velocity. Okay, otherwise in conductor, which is where we are having the electrons with the more drift velocity, that conductor is having the more mobility. The conductor which is having electron which is having less drift velocity, they are having the less mobility. Okay, but to bring this drift velocity, what should I apply now? Okay, by itself it doesn't move these electrons. Therefore we need to apply what now here? External electric field. External electric field, because on applying the electric field there is a creation of potential difference. If there is a creation of potential difference, electron starts to drift from one side to another side. Therefore the drift velocity is mainly depend on two factors. One is drift velocity and the applied electric field. Therefore we can say here drift velocity, magnitude of drift velocity per unit applied electric field is nothing but what now? Mobility. Therefore if I define it properly, the magnitude of drift velocity per unit electric field is nothing but drift velocity. Okay, now I can write in different way, because we already told that what is the equation for the drift velocity. It is E into E whole divided by m into tau. E into E whole divided by m into tau. Already we are having this equation, another equation. Therefore 1 by E. Therefore this E get cancelled. Therefore we are having another equation for the drift velocity, that is Vd is equal to, what can I write here? E into tau whole divided by m. This is another equation for the drift velocity. Another equation for what now? It's for the mobility, sorry. Another equation for what? Mobility. Therefore E into tau whole divided by m is the unit. Okay, now I want to bring another information here. What is the SI unit for the mobility? Already we know that. What is the SI unit for the velocity? That is meter per second. Okay, similarly what is the unit for the electric field? What is the unit for the electric field? If I check it, already I think in the last session I explained you one equation. E is equal to V divided by X, if you remember properly. Okay, where V is nothing but potential difference and X is the distance. Therefore I can write here it is nothing but potential difference, whereas potential volt per meter, I can write it here volt per meter. Therefore I can write it here volt per meter. Therefore on solving this I can say here meter goes to the numerator, meter goes to the numerator, and I will get the equation for a unit for the mobility as meter square divided by volt second. Okay, that is the SI unit for the mobility. Okay, now getting into the next part of our discussion, that is limitations of Ohm's law. Limitations of Ohm's law. First limitation is what now? V ceases to be proportional to I ಅಂತ ಹೇಳ್ತಾನೆ. ceases ಅಂತಂದ್ರೆ ಏನು? ಬಂದ್ ಆಗೋದು. ಯಾಕಂದ್ರೆ ನಮಗೆ ಓಮ್ಸ್ ಲಾ ಪ್ರಕಾರ ಏನಂತ ಹೇಳ್ತದ? V is directly proportional to I. Okay, as I increase the potential there will be increase in the current ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ. But practically ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, when I send the current through a conductor for a longer time, we are observing two effects. One is heating effect and another one is what now here, magnetic effect. Now magnetic effects ಅನ್ನ next chapter ಒಳಗಡೆ ಕಲಿತೀವಿ. ಈ chapter ಒಳಗಡೆ heating effect ಮಾತ್ರ ನಾವು focus ಮಾಡೋಣ. Therefore, on sending a current through a conductor for a longer time, okay, there will be one point, there will be change in the shape of the conductor. If there is a change in the shape of the conductor, then this proportionality won't be remaining same. ಅಂತಂದ್ರೆ ನಾನು ideal condition ತಗೊಳ್ತೀನಿ ಮೊದಲಿಗೆ, that is V versus I. I'll take a V versus I. Okay, I'll put some data now, voltage and current. If I put it now, okay, let us say for a 1 volt I am getting a current of how much here, 2 ampere. Similarly for the 2 volt I am getting a current of 4 ampere. For the third volt I am getting a current of 6 ampere. And then really current hang change ಆಗ್ತಾ ಇದೆ, it's changing linearly. Therefore this one is the graph when we are getting the current and proportional, which are both are linear to each other. But if I do the same thing for a longer time, what will happen? The conductor get heated up, there will be the variation in the dimension in the body. As a result, it deviates from what now, ಪ್ರಪೋರ್ಷನಾಲಿಟಿ ಅಂತಂದ್ರೆ ಗ್ರಾಫು ಏನಾಗತ್ತೆ, ಈ ಯೆಲ್ಲೋ ಲೈನ್ ಏನ್ ಡ್ರಾ ಮಾಡಿದ್ದಲ್ಲ ಅದರ ಪ್ರಕಾರ ಬರ್ತದ. ಅದಕ್ಕೆ ನಾವು ಇದನ್ನ ಏನ್ ಹೇಳ್ಬಹುದು, ಇಟ್ಸ್ ಅ ಐಡಿಯಲ್ ಗ್ರಾಫ್ ಅಂತ ಹೇಳ್ಬಹುದು. ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಇಟ್ ಆಸ್ ಅ ಐಡಿಯಲ್ ಗ್ರಾಫ್. ವೆನ್ ಯು ಗೆಟ್ ಇನ್ ಟು ದ ಲ್ಯಾಬ್, they are also having this observation. This one is a ideal graph, this one is a practical graph, this one is a practical graph. Okay, these are all observation where I can say we are losing our property of Ohm's law. Okay, therefore we are calling here V ceases to be proportional to I. On the basis of this discussion, I want to differentiate any devices, electrical devices, into two types. That is, one is ohmic device, and another one is non-ohmic device. Okay, now let us see what are the characteristics and what are the differences between them. Okay, now when I say what do you mean by the ohmic device, which satisfies the Ohm's law, those all devices we are calling it as ohmic devices. For example, any conductor you take, any metal conductor you take, they are all satisfying what? Ohmic properties. Similarly, which does not obey the Ohm's law, those are all called as what? Non-ohmic device. For example, in the diagrams you can see that is the diode is one of those type where it does not satisfy the Ohm's law. Similarly, the transistor, which is having 3 ends, this diode is having always 2 ends. Then these are vacuum tube, which we are studying for the modern physics studies. Okay, therefore all these apparatus or devices we are calling it as non-ohmic device. Similarly, now we will take a next difference between them. Okay, the next difference tells that V by I is equal to R. We know that V by I is equal to R, where R defines the resistance. This equation holds for the ohmic also, and remember for the non-ohmic also. Okay, this is very important point. This equation will be holds good for ohmic devices and both non-ohmic device. Even though these are non-ohmic, we can use this equation. Okay, then third point tells that here R is always remaining same. Here R is always remaining same for ohmic device. For example, if I take a copper, okay, if it is having a resistance of somewhere 4 ohm, okay, and for if I take a aluminum, it is having if somewhere let us say 5 ohm, then for all the aluminum it is having 5 ohm itself, and for all the copper it is having how much now? 4 ohm itself. It doesn't change. But when I come into the non-ohmic device, this there may be chance that R is a variable. R is variable. It is depending on many factors. For example, diode and transistor, if I take it, there are many parameters we are observing where the resistance is changing. On changing the potential differences and corresponding current. The detailed discussion of diode and transistor we are doing in the last chapter of our syllabus, that is semiconductor physics. Okay. Similarly, we have to study the fourth point, that is okay, examples. Okay, that is metals are good examples for the ohmic device, and transistor and diodes and vacuum tubes are what now here, non-ohmic devices. Okay, this is how we can differentiate the type of the material on the basis of idea of Ohm's law. Okay, then second limitations tells that the current and voltage relationship varies with the change in polarity of the applied potential difference. ಅಂತಂದ್ರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನನ್ನ ಹತ್ರ ಯಾವುದೋ ಒಂದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸ್ ಅಂತ ತಿಳ್ಕೊಡಿ. ಲೆಟ್ ಅಸ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಹಿಯರ್ ಸಮ್ವೇರ್ ಡಯೋಡ್. ಓಕೆ, ಇದನ್ನ ಏನ್ ಮಾಡ್ತೀನಿ, ಬ್ಯಾಟ್ರಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, I'll make it here positive and a negative. I'll make it here positive and negative. Let us say I'm getting corresponding to we are getting some current values. Okay, but for the same material, for the same diode I am taking here, if I change the polarity ಅಂತ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಪಾಸಿಟಿವ್ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಮತ್ತೆ ಪಾಸಿಟಿವ್ ಮಾಡ್ಕೊಂಡೆ ನಾನು. ಬಟ್ ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಇಲ್ಲಿ ಉಲ್ಟಾ ಮಾಡೋಣ ಅಂತಂದ್ರೆ I'll make it this one as negative and this one as positive. ಓಕೆ, ಅಂದ್ರೆ ಇದು ನೆಗೆಟಿವ್ ಆಯ್ತು, ಈಗ ಪಾಸಿಟಿವ್ ಆಯ್ತು. ಅಂದ್ರೆ ಏನ್ ಚೇಂಜ್ ಮಾಡಿದೆ ನಾನು, ಪೊಲಾರಿಟಿ ಚೇಂಜ್ ಮಾಡಿದೆ. ಯಾವಾಗ ಸೇಮ್ ಮಟೀರಿಯಲ್ ತಗೊಂಡ್ರು ಕೂಡ ಪೊಲಾರಿಟಿ ಚೇಂಜ್ ಮಾಡಿದೆ ಅಂತಂದ್ರ ವಿ now is not directly proportional to I. ಅದನ್ನೇ ಹೇಳ್ತಾನ್ರಿ ಅವನು, current and voltage relationship varies with the change of polarity of applied potential difference ಅಂತ ಹೇಳ್ತಾನೆ. ಈಗ ನಾ ಒಂದು ಸಣ್ಣ ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ತೀನಿ so that we can be comfortable how the data will be changing now. Let us say I am taking same this diode here. Okay, that is connected with some battery. Okay, generally it is having two parts for the diode. It is positive side and it is negative side, and it is also positive and it is negative. Now you can see here I am connecting positive to the positive and negative to the negative. Moment when I make it now, let us say I'll apply the potential difference in stepwise now, voltage and current. If I do it now, okay, now for let us say for a 1 volt I'm getting a current of somewhere 2 ampere. Okay, for the 2 volt I'm getting somewhere 5 ampere. Okay, for the 3 volt I'm getting somewhere 9 ampere. Okay, now similarly for somewhere 4 volt I'm getting somewhere 15 ampere. Means you can see the change what I'm observing, it's not a periodic, but even though I'm getting some graph for that, that is corresponding to voltage and current. If I draw it, okay, the current is abruptly changing, therefore corresponding to voltage we are having the graph something like this one for a voltage versus current when I am making in this way. But if I change the polarity, if I change the polarity, okay, that is already it is positive, I told you it is negative, but I'll change the polarity. Let us see what will happen now. Okay, I'm connecting negative to this side and positive to this side. Okay, when I do it experimentally, the observation is very different, that is voltage and current. Okay, here I'm applying the negative voltage. If I say the -1, -2 and -3 volt, -4 volt, if I apply in the beginning, there is no current for a certain value. Okay, for even though for the same diode I am using, ಇಲ್ಲಿ ಏನ್ ಡಯೋಡ್ ಯೂಸ್ ಮಾಡಿದೇನಲ್ಲ, ಸೇಮ್ ಡಯೋಡ್ ಯೂಸ್ ಮಾಡಿ ಬರೀ ಏನ್ ಚೇಂಜ್ ಮಾಡಿದೆ ನಾನು, ಪೊಲಾರಿಟಿ ಚೇಂಜ್ ಮಾಡಿದೀನಿ. ಪೊಲಾರಿಟಿ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ನೋಡ್ರಿ, ಫಸ್ಟ್ 1 ವೋಲ್ಟ್ಗೆ ಮತ್ತೆ 2 ವೋಲ್ಟ್ಗೆ ಏನ್ ಬರ್ತಾ ಇಲ್ಲ ನಿಮಗೆ, ಕರೆಂಟೇ ಬರ್ತಾ ಇಲ್ಲ. when I make it -3, it is giving somewhere 15 ampere. Okay, I'll correct some more values after some time. Now -4 ಇದೆ ಅಂದ್ರೆ it is coming to somewhere 90 ampere. Remember the what the current I am obtaining for this experiment, it is in terms of milliampere, remember. Okay, and if I observe the current values for this data, it is in terms of microampere. Means I can say in this section, in this type I am getting the more current. For the same system, when I get into this system, for the same system I'm getting the very less current. Only the change is what now I am changing the polarity. Antandre on changing the potential difference, on changing the polarity of the battery, we are getting the different characteristic. If I draw the graph for the second condition, the graph somewhere look like this one. Okay, therefore these are the differences we are getting from the Ohm's law, which is directly proportional to I. Okay, now the third third point is, that is the relationship between the V and I is not unique. Unique ಅಂತಂದ್ರೆ ಏನು, ಒಂದೇ, ಸೇಮ್ ಅಂತ ಹೇಳ್ಕೋಬಹುದು. Okay. Okay, the relationship between the V and I is not unique. That is more than one value of V for the same current. Okay, if I draw the graph here now, some graph I'll take it here. Let us say I'll take it here voltage, and if I take it as current now. Okay, I'll make some current values here: 1 ampere, 2 ampere, 3 ampere, and somewhere 4 ampere. Okay, now if I plot the graph, okay, for some characteristics, some experimental data, if I check it now, okay, this is the graph we are obtaining. Now you can see here, for the same current value, for the same current value, we are getting the two potential differences. We are getting the two potential difference. That is, here one potential difference we are obtaining, and here another potential difference we are observing. For example, if it is somewhere 1 volt, 2 volt, okay, it's a 2 volt, and somewhere if I take it as 3 volt, antandre for the 1 volt also I'm getting the 4 ampere. For the third volt also I'm getting how much ampere? 4 ampere. Is it possible? Okay, if I ask you that is V is directly proportional to I, it is very clear. Now let us say if I apply the potential difference of 1 volt, let us say I'm getting a current as per our diagram 4 ampere. Okay, but if I increase the potential difference to 3 volt, why, what must we have? The current what we are obtaining, it must be greater than the 4 ampere. It must be greater than what now here, 4 ampere. But what we are getting as per the graph, we are getting the same current here for the 3 volt. Therefore this is not possible. This is not possible, even though we have observed in some experiment by taking different electronic devices. Therefore we are saying that Ohm's law won't be hold in all the conditions. There is some restriction for the application of Ohm's law, but even though it is a standard one we are using widely, and another freedom given by this equation is it can be used for the both ohmic device and in the non-ohmic devices also. Therefore we are not much focusing on what now here, that is limitations of Ohm's law while studying the different apparatus. But keep in your mind what the 3 points what we have discussed, that is V ceases to be proportional to I. V is directly proportional to I is never be satisfied when I going for the greater temperature. And second one is on changing the polarity of the battery for a given electronic device, the graph is not giving the same result. Similarly, the third one, that's V and I, is not unique. Okay, therefore these are the 3 points we have studied regarding what Ohm's limitations. Okay, okay, these are the today's discussions. In the next session, I think if possible we will get into the numerical part. Otherwise we will go through some equations, that is regarding in-depth study of what now resistivity. We have to do it in the next session. That is the equation we have derived, that sigma is equal to ne square to whole divided by m. I think that is the one equation. We have to analyze that equation for the classification of materials, that is conductor, insulators, and the semiconductor. Okay, it's purely depend on the study of the graph. Okay, we'll do it in the next session now. Okay, now for any doubt and discussions, you can message, otherwise call at this number. Okay, we'll wind up today's session. Thank you.